Okay, hello. So I'm going to be trying to do this video a bit slower because I do tend to talk quite fast because I tend to have a lot to get through. But in this example, we just want to make a flowing curve along a surface stipulated by Sealam. Don't know if I'm pronouncing your name right, I'm sorry. And they wanted to basically have a flow field going around an object, stuck to the object, and having 2 points connected to each other. So the first step in my mind is to make the points at least flow across the surface. So let's start out. Let's go grab a geo node and let's figure out which test geometry we're going to use. I don't know. I don't mind whichever one we want, but I'm going to use the. Let's use the PCAD for now. And I'm just going to turn off the shader because I don't really need it. I'm also going to hit save and just going to save test. Not a good idea to just save it out like that, but this is just a quick video, and I don't. If the hip file crashes, then I've got a backup at least. So let's start out by scattering first. So we've got our points there. I tend to turn off this relax iterations. I'm going to shut to about 3000. I'm going to keep it like that. And then I'm just going to say pop network. PopNet is basically just a .NET, but it's auto filled out this pop object and the pop solver here. I'm also going to change my background to dark so that we can see the points a little easier and dive in. I'm also going to turn off this guide. Straight away, nothing's happening. So it is using the first context geometry, which is the first input here. I'm just going to say all points. It's going to be adding points every frame. So we've got about 156,000 points. So let's start out by making it rotate around. I wrote out how to do this in Vex, but I'm going to try my best to do this in VOPS instead. So let's go pop VOP, dive inside. And what we want to do is start out, I want to make all the points suck into the middle. And I'll explain why in a moment. So I'm going to say pop, I'm going to say subtract. And the way that we can get this to work is by creating a vector. So I'm going to jump to Photoshop here. I'm going to grab a pen like this so I can draw. I'm going to set it to a bit darker. Okay, so let's say that we have a vector here, and let's say we have a point here and a point here in the array. This is just a 2D array here, a 2D vector, I'm sorry. So this is X and this is Y, although that looks more like a Y there, my bad. And what we're doing here is with something called vector math, or basically it is just math, but it's combined vectors. And the way we can do this is we have the X and Y component, so X and Y component here. And we subtract this point here by this point. So what this will do is it'll make a new vector which points towards that vector with the magnitude as well. So let's say this is 3 and this is about let's say this is both 3, so 3 and 3, and this is 1 by 1. So 3 take away 1 is going to be 2, and 3 take away 1 is going to be 2. Now this means with vectors we have what we want to do is we like them to have them normalized, which means that X plus Y plus Z will all, if they're all added up, they will equal to a whole number of 1. So, and when we have something like this where it's 2 and 2 in direction, this is basically saying it is this would normally be 0.5. It's quite easy to calculate since they're both the same number, which equals to 1 times by 0.5 times 2. That should just be 4, I believe. My math is not my strongest point, I'm sorry. That wasn't 0.5, was it? It's not letting me do. That's because I'm in programmer mode. Yeah, 0.5 times. Okay, 1 times that. Yeah, okay. So basically, that's what we want to do. If it's just this 1, then we normally just times it by 2. Because it's 0.5 plus 0.5, which equals 1. We times it by 2 to get 2. So then what we want. So that's what's going to happen here. If I create. So if I take this position here and I subtract it by nothing, or let's just say a constant, so we know exactly where it's going to be. So I'm going to say constant, I'm going to say vector. And now this is just going to go into the center, so it's 0 by 0 by 0, which is the center. And I'm going to plug this into the velocity here. Actually, I'm just going to plug it into the normal so we can visualize it. If I jump out and I do 1 frame, and I say visualize the normals, we can see that they actually are pointing away from it. But what's going to happen is, so these are pointing away, the vector trail is going to go pointing the other way. And you can see that they're all at different lengths. So this length of this normal is longer than this length here. So what we like to do is we like to normalize this. So they're all equal to 1, like so. Okay. What we can do then is we could just plug this into the velocity. And it's just going to keep pushing out. What I normally like to do is I normally like to add this to the velocity, but this can introduce some unusual things where it just goes too fast. So I just tend to just set the velocity directly like that. And you can see it's pushing outwards, so if we want to go the other way, we can just switch this. So I'm just going to shift R, and it's going to switch. And now it's going to be stuck into the middle there. You can see it's a little normalized like that. So what I'm going to do is I'm going to go to birth, I'm going to say negative, and I'm going to say interpolate source forward. That's just going to look a little bit nicer. Okay, I want it to go around the other way. And what we can do here is we want to say get the cross product between this. So since we've got a vector, let's go to back here. So let's just scrub this, make a new layer, scrub this. So if we've got a vector which is pointing this way, I want to go around. So what we do to get this angle here, which is about 90 degrees, we do a cross product between this and an up vector. In the case of this one here, I'm just going to set the up vector to be up, which is going to be 0 by 1 by 0. This is going to give us this is just going to angle the vector around this way, basically. I'm going to visualize this, and we do like to keep these normalized as well. So I'm just going to go like that. So I'm going to go cross product between this position and the up vector here. I'm just going to plug this into the normal straight away, and we can see now that we actually are turning around in that form. So let's just go back and plug this into the velocity. What's going to happen is it's now going to spiral around. In this case, though, what we also want to do is I'd like to keep this to the surface of the geometry. So I'm going to go up and I'm going to plug into the second input, the surface here. Jump back in, and I'm actually just going to say inside here called minimum position. What this is going to do is it's going to take the position inside here. I'm going to add the result, I believe. No, hang on. So what I want to do is, it's easier if I go and actually just do this in Wrangle, honestly. So I'm going to say pop Wrangle, and I'm going to say at p equals min pos, and then I just need to set the incoming, which is just going to be 0, I believe. It's not, so let's just quickly go and Google it, what minpos is for the vex code here. So it'll take in the current geometry that it's trying to target and the current position it's currently at. So I'm going to say at point, like so. And you're going to see it's not really going to work straight away because I need to go into my inputs, and the second input is going to be the second input here. And now we can see it is now going along the surface like so. So what I now want to do is I want to, instead of making it go around just the center, I want to guide it. So there's a few ways we can do it. I believe we can do something like a hair guide. I think I did this last time. So we've got guides, got skin. So let's take a look. There's simple ways of doing it basically, but let's just try and draw a curve. In the draw curve, we can say projection object. Go into here, and under projection, I can say geometry. And I believe what I can down do is I can just go like so, and that'll basically just project it along for me. It's not going to look perfect, I know. So what I'm going to do to fix up that horrible curve, I'm actually just going to reset it. I would love it if it would be able to just slice it, honestly. Projection, send rays, send UVs, trim curves. So let's try that. I don't. No, okay. So I do want to trim curves then. So I'm just going to go around a bit like that. Well, honestly, I'd like it to go a bit more in this type of direction here. So it's going like a strap around, basically. Okay. So I'm just going to have it at like 1 here, and I'm going to fix this up. So I'm going to say fuse. I'm going to push this right up. I'm going to say resample. It's going to look pretty ugly, honestly. I would like it if the curves would meet up properly, but they're not going to, are they? Another way we can do this, I believe, is if we do like a trim. What was it? I think it's trim. I'm not too sure if it is trim. There's like a cut sort of thing. A way we can basically cut along like a curve. Probably a clip. A clip may work. So if we go clip, I'm going to turn off the normals as well. I'm going to angle it a little bit like that, and I'm just going to bring it down. So it's about there. And I'm just going to make it so it's only just like connecting around one curve, so it's like that. And what I want to do is I want to say no, I'm just going to keep one curve like that. I'm going to group the edges that are unconnected. So I'm going to say edges, edge is the group I'm going to call it. I'm going to say include by edge, include unshaded edges only. And then I'm going to basically blast out everything that is not that. So I go to edge. I'm going to say delete non-selected. That's not looking great. So what we can probably do is if we can say, let's say group promote. And let's see how we can make it a little bit nicer. This is going to the points. Let's go to primitives. Include elements only. Nope. Okay. Ideally, I'd like to just extract this. So let's see if we can extract just this. two, what was it, two lines. Nope. That'll convert to lines. It's going to delete my edge group. I wonder if I can actually bring it back. Nope, because they're all unshared now. What I'm going to try and do then is I'm just going to can I select this only to points? I can. Cool. So what I'm going to do is I'm going to make a quick wrangle here. And inside this wrangle, because these are all now points here, what I'm going to do, I'm going to say if I'm going to do an int PC open. I'm going to say PC, no, PC, just PC. Is going to be PC find. There must be an easy way. Let's just see if we can group transfer. Group transfer. Group transfers can be quite slow, which is why I'm a bit hesitant to do that. And I'm going to say edge. Apparently it has got the edges. So let's blast out everything that's not in that group. It's just not showing up, I hope. Let's go edge and delete non-selected. And there we go. And now we have a little edge going around. I'm going to resample it. And maybe it's not even resampling. That's a little unusual. So let's take a look at the numbering of these vertices. Let's fuse them. The numbering is completely off, which is a little annoying. Let's see if we can sort them by the connection edges. So sort by vertex order. So 0, 1. It's not quite perfect, honestly. These two are mucked up here. So it goes 0, 1, and then it switches around that and goes that way, which is very annoying. Okay. That was kind of a waste of time. There should be a way to just draw curves around this. I think. Apologies, I just got a text. There should be a way to just guide curves, basically. So I don't think that was it. Oh well. So we'll try with this. We will try with this. I don't think it's going to work too well, but we will try. The way that you make it will probably be better. It's up to you how you would make it. We've got something like an edge divide, which kind of helps at times, but it's not great. Anyway, so let's go to better yet, let's go add, delete geometry, and then say connect adjacent pieces. I'm still going to try and fix this because it is kind of important. I'm going to say adjacent pieces from this. Oops. Each point needs a unique name, so I'm going to quickly make a unique name. So I'm going to say s at name equals sprintf, and I'm just going to call it p underscore d. So that was a p underscore percentage sign d. And then I'm going to say at point num. What that's going to do is it's going to say for each point num, it's going to give me something like this. I'm going to increase the search radius a little bit. I'm going to say max action is going to be 2. Max search points is going to be 2. Honestly, I don't like how it's not doing it like that. I would like it so it's just like 1 point between each, but it's not going to let me, it seems. Okay, whatever. It's a curve. It's something. Let's see if we can resample this curve. We kind of can. So that's fine then. Whatever. I do not mind. I'm going to do a poly frame. And the poly frame, what that's going to do is if we go into my normals here, we can see there's no normals currently. What the polyframe is going to do is it's going to give us a normal. Should be. It's not showing us a normal, and I've mucked that up. I'm very sorry. Where is it? There we go. There it is. I was clicking the wrong one. I'm going to set it to 2 edges. Normally that does help. And that's basically just going to, it should be following the curve around, but it's not. So let's get rid of that. It should basically be following, it's not, which is very, very, very annoying. Which is why I tend to use like an actual drawn curve around. Another thing you could do instead of this is use like what am I looking for? I'm looking for it's not a curve, it's a circle. Thank you. And the circle, I'm going to set it to a polygon. I'm going to increase the subdivisions here. I'm going to set it to ZX plane. I'm just going to rotate it a little around the X and a little around the Z. Like so. And then what I'm just going to do is I'm just going to ray it. So I'm going to plug these in. I'm going to switch them. And you're going to see it's going to do something like this. I'm going to then increase the scale a little bit. And I'm going to bring it down because I want it to just clip through there, not through the actual mouth. And inside here, I'm going to make an attribute wrangle. And I basically want to make the normals face inwards into the center. And one way I can do that is I can get the center, I can say vector cent. I'm just going to call it center, and I can say get bbox center. And I'm going to say 0 because it's just a 0 point there. I'm going to say at n equals center. So, and normally that'll work, but let's just try at p minus at center, and that'll now they're facing outwards. I want to negate this. The easiest way to do that is just say at n equals minus at n. That's going to negate it. We're also going to normalize this so that we don't have anything funny. And then the ray should work like so. Finally, what I'm going to do is we can do minimum distance or project rays. I like project rays on better. Finally, I'm going to go convert line. Like so. And then I should be able to now do a resample around this. I'm also going to smooth it. If I smooth it at the lower resolution, it'll have a harsher smooth. Okay. So I'm just going to grab this. And I'm also going to just move this to the side. So now we should have our normals going around that way. I'm going to plug this into the third input here. And inside of my pop-bop here, instead of this subtraction of here, I want to actually do something else. And this is going to be a little weird, especially if you use, say, so there's inside VOPs we have to use an if statement. typically. However, this can be incredibly hard to do, and it's not something I enjoy doing inside VOPs. I do this in Vex only. So with that being the case, I'm just going to show you how to do it without the if statement. It will have some errors, but the way we're going to set it up, it's not going to affect us too much. So what I'm going to do is I'm going to say PC open, which is going to give us a point cloud open. What this does is it makes a sphere around the current position, and it's going to capture all the points there. It's going to get, after that, once it's got all those points, so let's say we set the number of points it can collect is 10. It's going to collect about 10 of those points if they're in the search radius, which is 0.1 for now. And we do something called a PC filter, or a point cloud filter. And what this is going to do is it's going to get all those 10 points and it's going to average them out. And it's going to get the attribute here, which is the attribute P. And if the P is around here, it's going to get the average of that. And it's going to spit out one positional value. So instead of this one, I'm going to plug this in here. Inside here, so this is coming into the third input. I'm going to go into my point VOP, my pop VOP I should say. Go into inputs, and under the third input here, I'm going to say get the third context geometry. Inside here, then I'm going to wire this out into my op input here, and I'm going to wire the position of our current search radius into here. Okay. This is going to give us the PC filter of position, and instead of position, what I can do is I can then say just get the normal, and what this should do, I say n, is it should now push us along the normal direction. You can see it's kind of working like so. To increase this, what I'm going to do is I'm going to set it to about 2000, and I'm going to set this to about 50. And now you can see it's working like so, going around that area. One thing to note is you can obviously set this down to be smaller, so say like 2. It'll work just fine. In some cases it may look better. The only issue that you can get with this is that some points may just appear not to work, and that's where the if statement will come into it. Let's just turn off this pop wrangle so that we're not minimizing it, and you can see it is actually going around. Now one thing that's going to happen is you're going to see like these points have stopped moving, these points have stopped moving here, they're not going any further out. The reason for that is because of the search radius. I've set it to 2. So what we normally like to do is I'm going to go to PC filter up here, and I'm going to subtract the position instead. And now what's going to happen is it should ideally, oh wait, hang on, I need to actually add these two together. I'm not going to include the cross product. Now this is going to suction inwards, and if you want it to be a bit less, what you would normally do is you would just multiply this by a constant. So you would say multiply this by about 0.1, or you would just you'd also turn off this normalize here. Was that a normalize or was that a subtract? That was a normalize. I'm going to set it to about 0.3, and I'm going to turn my minimum position back on. And now we're going to see we get something a bit like this. And you're going to get like this little ring around here, which is the what the minimum position is doing, which is what this part here, the subtraction, is doing. Okay, I don't really want the subtraction, so I'm just going to set it to just be following the normal. And now that they're all following the normal, what I'm going to do is I'm going to jump out into here. Let's jump out. Let's go dop import fields. I'm going to drag and drop in here. I'm going to say pop object, and then I'm just going to say geometry. and I'm just going to say no change. That's just going to give us our geometry. I'm just going to also delete some of the attributes. So I'm going to say attribute delete. I'm also going to delete the groups. So I'm going to say group delete, all of them, attribute delete. Let's see, which ones do we want? Well, I'd like to keep the velocity. I'd like to keep. I'm not gonna keep the ID. That's all I really wanted. Okay. So now I've just kept those two. I've kept the velocity so I can visualize it. So what I can do here is if we go like a fluid. Let's see. There was a fluid surface. Fluid. Yep. That's not the right one. So if I chuck this into here, it's going to start meshing it. I'm just going to say particles, so it's not going to do anything, and I can just visualize the velocity. I can turn this right down because I know the velocity is not going to be that high. If you wanted to, you could also add some noise into here. I won't show how to do that. You should be able to figure that one out. But what I'm going to do now is I'm just going to show you how to connect these points, and what I'm going to do is I'm going to right click on this material property, so I'm just going to turn this to pixels so we get like a little finer view. And we've got about 1,000 points. Let's keep it to about 33 for now. And I'm just going to connect every single point to every second point. So what I've done here, over in here, in this file, is I've made a small Legolizer, which took ages because it was quite hard to do. And the main meat of the function is in here, which is quite big, I admit. But there were some points to it as to why. And I'm going to do my best to explain everything and how it's going to work. And our setup's going to be a little bit easier. So I'm going to start out by just making an attribute wrangle. Here, I'm going to set it to detail, so it's only going to be run once. I don't want to run it over every point. I'm just going to run over it once. Now, let's dive back in here and let's take a look. What I'm going to do is I'm going to make a list of points. So let's say points. And a list is going to be made out of brackets here, like so. And each one is going to have like the numbers. So 0, 1, 2, 3. So what I want to do is if I'm on point 1, so point 1, there's probably an easy way of doing this, but let's say point 1 is equal to, point 1 is going to say 0 and 1. Now the problem with this though is I can just say point. Okay, so point 1 and point 0 are going to have these two. It's going to have these duplicated. But the problem with that is that if we dive inside here and we go to open these up, and let's just go really close, we can see that 1,700 is really close to 9,000, and it's not really close to a number of the same value. So what we want to do is we want to do like a point cloud. What the point cloud is going to do is I'm going to have a position here, and I'm going to make a cloud around it, a spherical cloud, and of all the other points near it. And I'm going to say get the first one that's closest, which is just going to be the first one in the array. And then if that one's being used already by one of these up here, then find the second closest. If that's being used, then keep going. What this is going to enable us to do is just make sure that nothing is connected to 2 points at the same time. And we're just going to keep on adding this sort of thing to it. The problem herein is that it's just going to be a little bit hard to code. I'm going to do my best to try and explain it as I go, but if you do get confused, then it is a rather confusing thing to try and get. So I'm going to make an array first, an empty array of the used points. So I'm going to say int used points, and then I'm going to put square brackets around it, and that's it. That has made an empty array of used points. If I were to say, if I wanted to make that an attribute, I would say I, then the two square brackets at, let's just give it a name of points, and I'm just going to enable it to the same one. So use points. I can do that. And if I go into my geometry spreadsheet here, we can see we've got these use points. I can set this up to say array, and then I can give it some arguments. So I'm going to say 0, 1, 2, 3, like so. And we can see that we now have an array of points, an array of numbers at least. We can have a different type of array. We can have vector arrays, we can have string arrays, but I'm just going to keep it as an integer array. And if I want to go over every single point, I'm going to use something called a for loop. Now, the for loop is just going to go over every single, it's basically going to have an incremental value, and it's going to have the current point, the incremental value, and it's just going to keep looping over each point. So the way we can do that is we can say for, and you notice we've got the for each and 4 points. I've never seen 4 points, but I don't think we can use this one. So we've got for and for each are the two most used ones. For each is used if you already have an existing array, and we will be using it. But right now we don't have an existing array of points. Even though we've got these used points, we don't want to be using this one. So what I'm going to say is going to say for brackets int ii equals 0. So I'm initializing an integer value of ii at 0. This is our current iteration. You'll note that a lot of people tend to just use the I. This is the way I use it is the programmatically semantic, because I have worked with lots of code in the past, major code databases in the past, and if you go Control F and you to search for a specific function and you type in I, you're going to find a lot of different functions that are not going to be a for loop. So we tend to do I tend to use the double inside here. I'm going to put a colon. I'm going to say II is less than, but now let's just say 100. I'm going to end up going to say endpoints, like so. But right now I'm just going to say, let's say 200 to start out with. And then and I'm going to put another colon, and then I'm going to say II plus plus. What this means is that at the end of the loop, increment the value by 1. I'm going to set it up like that. And there we go. If I didn't have this in here, if I just say II, you'll notice that it's cooking, because what we've made here is an infinite loop. You can't do that. Okay. So currently this is running over for the for loop 200 times. What I'm going to do is I'm going to start out by saying, hey, make an array of hit points. So I'm going to say int hit points. I'm going to keep it as empty as well. This is just going to hold all the hit points that we're going to find. And then what I'm going to do is I'm going to initialize our current point to our current I value. For some reason, someone just phoned me and then hung up. Okay, and there's a good reason. It's because I want to be able to change the point value later on in the code if I need to. Now, what I'm going to do is I'm going to create I want to get the current position of the current point. So I'm going to say vector position is equal to 0.0 p for the current point. This is going to give us a positional data that we need. I'm then going to say int. Actually, I don't. I can actually bring these hit points down to here. Hit points like this. Int hit points is equal to PC find. This is going to give us like an array of all the points that's found. I'm going to say 0 because we're going to go over the current 0 input. P at P, or better yet, we're going to say pos because this is our current position. And then we have a radius and we have the amount of points. I'm going to set this to about 20 and this to 20. So we're going to have a radius of 20 meters and the amount of points we can hold is 20 points overall. Okay, now what I want to do is I want to do a for loop, another for each loop. And I want to say, before I do even do that actually, I want to showcase a little something. So what I'm going to do is I'm going to say set point attribute, and this is going to set a point attribute on every single point that we're running over. Let's say 0. I'm going to say hit points as a name. I'm going to say the current point is what we're going to be adding the attribute to. I'm going to say the hit points is the attribute we're going to be setting. And then finally, I'm going to say set. This is based, if we don't say set, then it won't actually set the value. If I go to here now, we can see that we have hit points. And you'll notice something weird is that even though this is 0.40, we're getting 0.40. Even though this is 41, we're getting 0.41. So we want to actually remove, we don't want to be going over the first input. So there are ways you can actually remove this, but right now I'm just going to do because I'm going to do a for each, I can, instead of doing a for each, I can just do another for loop. I'm going to set int ii equals 1, so I'm going to miss the first one. ii is less than the length, which is going to be len. This is going to count the amount of points in the array. I'm going to say hit points, ii plus plus, and you're going to notice something here that we're using ii again. So I'm actually just going to change this to jj. And we do ii, jj, and then kk. That's just how we do it grammatically. So now what should happen is we should not be running over the second point, over the first point at least. And what I want to do now is I want to say, hey, check this point. If this point exists in the in these use points array, don't use it. Excuse me 1 second. I did not expect to get a phone call. Just another scam. How wonderful. Okay. And I might be, I'm starting to confuse myself, honestly, with this. But right now, is I want to say, hey, now that we've got this, just, I want to check to see if it's in use points. And a method we can use is we could do something called, so there's a function in there called find, I believe, or search. But I'm not going to be using that one because it, in my other file, it actually threw a few errors. So I'm going to make my own finder. So I'm going to say int FIA. I'm going to say FIA like that. And what this is going to stand for is just basically find an array. I'm going to say int found equals 0, return found. So it's not going to yell at us anymore. I'm going to have two arguments in here. I'm going to say int loop, which is going to be the current loop that we're going to be the current array we're going to be looking for, and the current number we're going to be looking for. And then I'm going to say for each int ff inside the loop. So basically we're going to be looking for the current point. Find, I just called it ff for find basically. I'm going to say if ff equals finder, then I'm going to say found plus plus, so I'm going to increment the value, and then I'm going to break. Break is going to basically stop the loop, and it's going to go to the next line, which is going to be our return found. So what I'm going to do then is I'm going to say, hey, because we're going for each loop, I want to get the current point. So int point number. And I'm going to say, hey, what is your number? The way we can do this, we can say hit points JJ. And that's going to give us the current number from our array. Then I'm going to say if point number, actually, if FIA point, and we're going to have a loop, which is going to be used points. So used points. If FIA point number equals 0, then I'm going to append this to our hit point. So we've got hit points here. I'm going to make one in here called hit point. Actually, I'm just going to say, I'm going to call this hit point. I'm going to call this found points, like so, just so I'm not confusing myself. So these are the found points. And I'm going to make another one. I'm going to in here. I'm going to say int hit points. And underneath here, I'm going to say append into hit points current point. And there's a reason I've got a space in here, and I'll showcase why in a second. And I'm going to say if FIA is 0 surface not found, then I want to append the current use this point to this hit points here. So I'm just going to copy this, and I'm going to say point num. So let's see if that actually worked. And what I'm going to do is I'm also going to say break here, and then I'm going to say else break. Actually, no, I'm not going to say break. I'm just going to go like that. I'm just going to say break, like so. And what I'm going to do is I'm now going to set the attribute, and I need to actually make these a little bit smaller to see. So I know I want to just visualize this array that I've made. I'm going to say set point array. Set point attribute. And I'm going to say 0. I'm going to say hit points. It's going to go to my current point, which is going to be the current II, not the current point. Maybe it is the current point. Probably is the current point. Let's go current point. And the attribute is going to be hit points. And then I'm going to say set. And we're going to see we're going to have a few points here. We're not going to get everything. So let's go. Let's say endpoints. And now every single point is going to have their own current point that's going to be linked to. However, we want to make sure that they're not hitting the same points together. And the way we can check this is if I say a new array, a new attribute wrangle here, and I'm going to say if the length of I at hit points, and I need to mark that up, at hit points is greater than 0. So we're going to say, hey, do you actually have the array? Then just add the primitive to it. So add prim polyline to the I at hit points. Like so. And you can see it's not quite working. We've got some points that are joined together badly. So we've got these 2 points joined together badly. So let's try and do a little bit better than this. So, whoops, did something wrong there. So even though we've appended that, we actually need to append hit points to the used points as well. So I'm going to say use points. I'm going to say append used points with our point number, like so. And I'm not too sure why that's taking a lot longer to do now. So let's stop that. Let's try and figure out why it's taking so long. Because it's trying to add a multitude of points to each point. So what I'm going to do, I'm just going to stop that. And now I'm going to say, hey, if you find this, so FIA, if the current iteration is inside of here, so I'm actually going to move this current point down. If the current iteration's in our use points, then don't do this current iteration, basically. And instead of using break, I can do something called continue, which is just going to basically continue down. So take a look, and now we say append. Huh. That is a little weird why it's taking so long. Doesn't normally take this long. Should not be taking this long. So I'm going to stop it. I'm going to say, hey, just do 200 points, please. Now what should happen? You should now see that only some of these have got points. That's fine. So I'm a little curious as to why it is, if I do, how many points have we got? We've got 33,000. So let's do 2,000. Let's do another 2,000. Oh, well, we've actually incremented it quite a bit. I have a feeling, so the use point, so the array of points is quite large, unfortunately. So what we could do instead is, oh, so it actually has actually finished. If we go to this now, we should be able to see some of these points not added together. So let's just keep going. So endpoints 0. I believe one thing we actually have to do as well is we also have to append the current point as well, I think. Which would make sense. So let's say append into use points this as well. Really is taking its time, isn't it? And there we go. So now each point, we're going to have some points, I'd say, floating off in the distance. And I have a feeling the reason it was taking so long is because of the this PC find. But that's basically how you do it. It is quite hard to do, but that's how you do it. So the reason I'm appending this is because I don't want to check. So if the point number is being used, then I'm going to say, okay, don't use the point number anymore. You're going to see we're going to have some unconnected points, about 800 points that are not being used, which is annoying. But if we made the search radius or the amount of points larger, then it would, well, for one, it would take longer. But for two, it would mean it would connect all the points. So let's just make this to be about 100, maybe 200, which means it's going to loop a maximum of 200 times, which is not really something we wanted to do, but it is something that we can do, basically. So if I now click off this, it's going to take a long time, but that's basically how you do it. As I said, it is quite hard to get to wrap your head around. You could technically do it the other way, where you connect the points that are closest to each other. Oh no, this is connecting points that are closest to each other. Sorry, but at the same time, you'd have to then have to iterate through each one and say delete this and delete that, and just keep one. Thank you. Which can prove to be rather difficult to do. You'd have to do a feedback loop over each one, which can get very frustrating at times. So this is for me, this was the fastest and the most simple way of connecting 2 points that are close together without connecting any other points. And hopefully what this means is that there will be some floating points, I'd say, but there are going to be no points that are connected together that aren't basically that shouldn't be connected. Looking over at Discord, I can see you've kind of amended what you're saying. So what we can do is I'm going to go into here. I'm going to say attribute wrangle. I'm going to say I at ID equals at point num. And because I'm not changing the scatter seed every frame, I'm going to keep it like this. I'm going to dive inside here. I'm going to go to my attributes. I'm going to say turn off add ID attribute because that can muck it up sometimes. I'm going to go to my attribute delete, and I'm going to say yes, keep the ID please. What we can then do is we can say add, and say by group, and I'm going to say by attribute, I'm going to say ID. That's going to give us these lines, and then I can now group each nth line if that makes sense. So I'm going to say group, group by range, like so, and I'm going to say select one of every two. Okay, that's not really what I wanted to do. So it's making so I can say skip groups of endpoints basically, and it's like a 2 every 2 points here, like so. But that's not really what we want. So I'm going to go back. I'm going to say by attribute here, and it's just going to delete these things. I want to let's see if we can do convert line, and let's see if these will actually split this up for us. Yes, it'll split it up for us. It still doesn't work. Basically, I want to select every point that's connected. Okay, connectivity. Let's say ID. If we go for loop for each primitive, like so, I'm going to go for each one. I'm going to say single pass, please. And then I'm going to say, hey, can I just get? I'm going to resample these. So I'm going to say resample each one so that they're a bit smoother. So let's go 0.5 just to give it a bit more depth, like so, maybe a bit more. Yep, there we go. And I'm going to then, I should be able to just do a group by range now. Group by range. And I want to say every second point. And you can see it's not really working. So let's go primitive points, and we're going to select every second point. Another thing we can do, because we've only got in polygons, what I'm going to do then is I'm going to say, hey, attribute wrangle. I'm going to say put an add down, like so. Okay, so delete geometry, and I'm going to say, hey, add for. I'm going to go to my detail. I'm going to say for int ii equals 0. I is less than n points, and we covered this earlier. I plus plus. I want to grab the current point and the next point, which is going to be, so int point or c point. This is going to be ii, and int endpoint, which is going to be next point, which is going to be I plus 1. And I'm going to say add prim, and I'm going to say 0 polyline between current point and next point. So what that's going to give us is it's going to give us 44 polygons. Now then, another thing we can do is if we wanted to keep doing this romantically, but let's just do this by the group by range. Now what should happen is if I go group by range, I say 2, we can see it's selecting every single second point. However, what we can also probably do, which might be a little bit better, is we can say, hey, check to see what current we are on. So I'm going to say if ii modulo 2 equals 0, then do this. And what's happening here is modulo is basically get the remainder. So if ii divided by 2 is equal to 0, because, well, okay, let's do a better one. ii divided by, so if 1 divided by 2, you're going to have 1 left over. If that makes sense. If you have 3, you divide it by 2, then you're going to have 1 left over. 4 divided by 2, you're going to have 0 left over. 5 divided by 2, you're going to have 1 left over, and so on and so forth. So that's basically how we can do that. If I go to for each and I go single pass, turn off the single pass, we can see we now have what you want. If we didn't do that, I'm just going to pop these out. I can go like this, and I can say blast. So I'm going to call this one Del. And I'm going to say, hey, blast out the Del. And that's basically what how you do that. Sorry if that took so long. I didn't actually read the comment. Hopefully that helped in some capacity. And I have to go. So I need to figure out who was calling. I think pretty sure it was a scam. But yes, thank you for watching. I'm trying out a new. I've got some tutorials on the way, and I'm trying out a new mic. So if you could let me know if this was any better, and if I was able to talk slowly and coherently. Okay, thank you.